In this video, I'm going to show you how to do problems 11 and 12 from page 240 in the book. I forgot in the last segment that I was going to show you the answers first so that if you have it right, you don't have to watch the whole video to see the answers. So here is 11 and here is 12. And I'll give you a few seconds to pause your video if you need to check your answers. And this way you can just skim through the video to get what you need. So I'm going to do these problems now for you. So for number 11, it wants me to give the answer for how many moles are in each of these different quantities. So for 11, they want to know how many moles are in 37 grams of iron. So I write down 37 grams of iron. Now I need the molar mass, which comes from my periodic table right here. I'm going to round to 4 significant digits, so 55.85 grams. Of iron are in 1 mole of iron. And now I'm in moles. I cancel out my units. I'm in moles. And when I do the division, when I divide 37 by 55.85, I get 0.662 moles of iron. For B, I am given 4.58 times 10 to the 22nd atoms of krypton. And I need to get to moles. I know that there are 6.022 times 10 to the 23rd krypton atoms, that's Avogadro's number, remember, and 1 mole of krypton. So when I do that division, I get an answer of 7.61 times 10 to the negative 4th moles of krypton. Now, notice with these answers, I need 3 significant digits. That's why I'm writing them the way I am, because up here, 3 significant digits is the smallest. Here, 3 significant digits is also the smallest. So I'm sticking with the 3 significant digits for that reason. And I'm also using scientific notation because I could put in the zeros ahead of it, but your calculator is probably already giving it in scientific notation, so keep that because it's easier also to write the correct number of significant digits. For C, I am given 3.25 times 10 to the 26 units of sodium iodate, formula units. I know that there are 6.022 times 10 to the 23rd formula units of sodium iodate in 1 mole of sodium iodate. And when I do that division, I end up with an answer of 5.40 times 10 to the 2nd moles of sodium iodate. Now, you could write that in standard form, but if you do that, make sure that you write it as 540 with a decimal point after it, because if you leave off the decimal point, you only have 2 significant digits, not 3. for 12. The problems here ask me to calculate the molar mass of the following compounds. So the first compound is N2O3. And so for this type of problem, remember, for compounds, I have to find the molar mass of the element and multiply it by the subscript, because that tells me how many moles of each type of atom are in the compound. So for this, I'm going to multiply 2 times the molar mass of nitrogen, which is 14.01, rounded off to 4 significant digits, grams per mole, times 3, because of the subscript behind the oxygen, and the molar mass of oxygen right here, rounded off, that's 16.00 grams per mole. So when I do the multiplication following order of operations, all of our math rules apply. I get 28.02 grams per mole plus 48.00 grams per mole. And when I add those numbers together, I get 76.02 grams per mole. That is the molar mass of N2O3. So if I wanted to measure out 1 mole of N2O3, I would have to, on my balance, put 76.02 grams. For B, I have Mg3N2. So to find the molar mass, 3 times the molar mass of magnesium, which when I look on my periodic table is 24.31, rounded off, grams per mole, plus 2 times the molar mass of nitrogen, which is 14.01 grams per mole. When I do my multiplication first, following order of operations, I get 72.93 grams per mole plus 28.02 grams per mole. When I add those numbers together, I get 100.95 grams per mole. Now this follows my significant digits because when I add, remember, I keep the number of decimal places. So I go to the hundredths. And then for C, I have silver nitrate. And so silver's molar mass is 107.9 grams per mole, which I get from my periodic table. Nitrogen is 14.01 grams per mole. Remember, I'm keeping 4 significant digits, plus 3 times 16 for the oxygen. Following order of operations, adding all of those numbers together, I get 169.9 grams per mole. Now this time I only go to the tenths place because for significant digits, this number here for silver only goes to the tenths. These two go to the hundredths. I can only go to the tenths when I'm adding. So this concludes the solutions for problems 11 and 12. I will do the other problems in another video.